Hey, what's up, guys? Chung here again. So today I want to talk about another LeetCode problem here. 1463. Cherry pick number 2. Hard problem. Okay, so let's take a look at this problem description. So you're given like a 2D matrix here, grid, with rows and columns, and then you have two robots. So one robot starts from the top left corner, the other one starts from the top right corner. And for each step, a robot can only moving down, right? And it can only moving down by one row. But on the horizontal level, it can move either to the left, directly down, or to the right. So basically, for each of the robots on each movement, it has three possible movements here. And then it asks you to find. Okay, so once this robot's at this one position here, location, it will collect the this the cherries on this box. And if two robots reach at the same locations, let's say for example five here, right? Only one of them will collect the cherry. Basically, this five will only be collected once. And it asks you by the time this robots reach the last row, what's the maximum cherries? What's the most maximum number of cherries those two robots can collect, right? So, so obviously this is going to be a DP problem, right? But the question is how can we solve this DP problem, right? Uh, so for the we have a 2D board here, right? So that's obviously a DP I and J, right? I and J here, right? And then but then we have two moving objects here, right? So that's will make us a third J1, J2 here. Basically, that will make this three-dimensional DP problem here. And so that's the first thing we need to be sure, right? And the second one is that with DP problem, there's a top-down and bottom-up, right? So, with this kind of problem, that's the starting point is a fixed positions, and then it travels down the road. And notice here, so the ending point, it's not a fixed ending point, right? We don't know. On the last row, it could be ended in anywhere, right? So then this like for me at least that makes this bottom up problem a little bit more difficult because unless we if we want to travel from top down here, right? Basically but by the end, let's say if we want to travel down from the first row to the last row, if we're trying to use bottom up solution, then by the time we reach the last row, we don't know like which element we should use, right? And to do the bottom up, one way is that you have to be basically you have to travel from the last row going up, and then okay, at the last step we know the leftmost point and the rightmost point. Those 2 points will be our final answer, right? Unless you travel from bottom up. And if you want to like do a more intuitive travel from the starting point to the end point, right? In this case, uh, you it's we have to use like the recursion call with the memorization to solve this problem. Basically, every time when we are at this current row here, right? The ith row, we collect the current rows, collect the current rows cherries, and then we do a recursive call for each of the possible movements on the next level, and then we do a recursive call, we return that method to the current one. And in the end, we just return this helper function. Okay, so with that being said, let's try to code this problem here. So basically, we're gonna have a DFS here, right? So it's gonna be a DFS here, gonna be the row column 1 and column 2, right? So that's our three parameters here. And okay, so with this recursive call, we're gonna have like the memorization problem here, memorization here. And first thing to check is that if row column 1 and column 2 is in the memorization, right? And then we simply return whatever we saved inside there, right? We save row column 1 and column 2, right? That's the first step. And then if the row reached the last row here, so actually m equals to a grid. Let me define some variables first. Length, and then n will be a length of the grid 0, right? So that's the rows and columns. Basically, if you reach the so when should we stop, right? We stop when we reach the last column, right? But when we are at the last columns, we still want to collect the uh current the last row's cherries, right? That's why we have to keep doing it. So that's why we cannot stop from n minus 1. We have to stop from n, right? Because for n minus 1, we still want to continue doing the followings. That's why we need to pass this n minus 1 to n. Basically, if we're reaching the n, which it means we are outside of this 2D grid here, right? We simply return 0 because there's nothing to collect there. All right. So okay, so now at the current row with the bottom with the robot 1 and robot 2 column locations. So we need to do two things. First, we need to collect the current row's cherries, right? Cherries equals to what? Equals to the grid row and column 1, right? And remember, we don't if we need to check if the two robots are in the same location. If they're in the same locations, we will only be collecting this once, right? Plus 0, okay? If column 1 equals to column 2, right? Basically, if the two robots are at the same location, we will be adding the second parameter as a 0. Basically, we're only collecting this current cell once, right? If they are not at the same location, then we'll collect both row and column, right? Column 2 in this case, right? Because if they are the same location, we can use either column 1 or column 2. It doesn't really matter. But if they're not, we have to be collecting both of the locations, right? And then the next step will be starting from this row to row minus row plus 1. We need to try all the possible ways, and right result basically result from next row, right, equal to 0. And how can we, so basically each of them have 3 movements, right? So, and we have 2 robots. That's why we need to have a nested loop here, right? Basically the I in range what? In range -1 to 2, right? From -1 to 1, basically. And J in range -1 to 2, right? That's how we do for each of the, basically we have to get all the combinations, right? Because for this one, it can be moved to left, down, and right. This one also left, down, right. To get all the combinations of those two robots, we have to do a nested loop, right? With both -1 to 1. And so basically a new new column 1, right? Gonna be the column 1 plus I, all right? And new column 2 goes to column 2 plus J, right? So, and now we can, before calling the calling the DFS method, we need to do a sanity check. We need to make sure the new column are still within the 2D grid, right? So that's, we do a sanity check if this one is within the range of n, right? That's the length of the sorry, the width of the 2D grid. Same thing for the other new column, right? New C2 to n less than n, right? If both of them are within the grid, then we can do this. We can do a, basically for each of them, we check. We check each of them, and then we get the max of DFS, right? Row plus one, since we're moving to the next row, right? And new column one and new column two, right? And then for the current level, what's the total cherries we have here, right? Total cherries we have here is the this one plus the cherries, right? We currently collected, right? And then uh, answer equals to this, right? So, and then before returning the answer, let's add these things to the memorizations result, right? So going to be row. The key is going to be the row, column, and column two, right? And the value will be, okay. So since it's a dictionary, we have to use a square bracket here. The value will be answer, right? That's how we do the memorizations, and then we simply return the answer. So here, simply return DFS plus 0, 0, and n minus 1. Okay, right? So yeah, let's try to run the code here. No, what? 24, 21. Huh. MN. Okay. Oh, sorry. Here. Equals to M. Yeah, M is the rows, not the N. All right. Let's try to run it. Cool. So it passed. All right. Just to recap what we have discussed. Typical dynamic programming problem. The difference here is first you have two moving objects. That makes this dynamic programming a three-dimensional state here. And the second one is second thing we have to be careful here is since the stop point is not a fixed place, right? But the starting point is a fixed place. It's so that if we want to get the maximum number or maximum result or minimum result by the time we reach the last row, right? To it's hard to get the value from the DP result, right? That's why it's better we use the top-down mechanism here. Basically, we start because we know the starting point, right? That makes us easy to start, and we start from here, and then we're just moving down the road, right? And then we do a recursive call on each levels, right? And then on each level, we'll be like getting the max position, the max cherries we can pick at this at the current level, right? And plus anything we can collect from the previously level. That's how on each level we're always getting the maximum cherries we can collect. sort of like a recursion plus a greedy method, right? Technique here. And in the end, and also don't forget to use the memorization, so we don't have to repeatedly compute the same same state more than one time, more than once, right? And then in the end, we simply return the answer here. So yeah, I think that's it. That's it for this problem. Yeah, very interesting DB problem. Yeah, that's why I gave it my own upvote. See, only 3 downvotes, which means this problem is it's very I think it's a very interesting problem. Everyone likes it. Okay, cool. I think that's it for this problem. Thank you so much for watching the videos and stay tuned. I'll be seeing you guys soon. Bye bye.